The topic is data link control. The data link layer transforms the physical layer, a raw data transmission facility, to a link responsible for node to node, it means host to host communication. Specific responsibilities of the data link layer including framing, addressing, flow control, error control, and media access control. First, we come to the framing. Basically, the data link layer needs to pack bits into frames so that each frame is distinguished from other system requires a type of framing. There are two type of framing. First is one is the fixed size framing. Second one is the variable size framing. Flow and error control. The most important responsibilities of the data link layer are flow control and error control. Flow controls refer to a set of procedures used to restrict the amount of data that a sender can send before waiting for the acknowledgement. Error control in the data link layer is based on automatic repeat request, which is the base transmission of data. Now we come to the protocols for noiseless channel and for noisy channel. For noiseless channel, the simplest and stop and wait protocol, and for noisy channel, the stop and wait ARQ, or it means automatic repeat request, go back and ARQ, selective repeat ARQ. So what is the noiseless channel? In the noiseless channel is the ideal channel in which no frames are lost, duplicated or corrupted. There are two protocols for this, simplest protocol and stop and wait protocol. This is the design of simplest protocol with no flow or error control. The sender sends data and receiver receives with the help of this simplest protocol. This is the algorithm for the simplest protocol, and this is the way from the sender request the frame and it arrives at the receiver with some delay. Then the stop and wait protocol. In the stop and wait protocol depends upon the acknowledgement when the sender sends its data, and then receiver send an acknowledgement when the sender gets its acknowledgement, then it sends its next frame. This is the algorithm for the stop and wait protocol. This is a simple example. This is a flowchart when the sender is sent its frame and it arrives at the receiver, and then from the receiver, when we get the acknowledgement, then it sends the next frame. For the noisy channel, there are three types of protocols. One is the stop and wait automatic repeat request, go back and automatic repeat request, selective repeat automatic repeat request. Error correction in stop and wait ARQ is done by keeping a copy of the sent frame and retransmitting of the frame when the timer expires. In the stop and wait ARQ, we use sequence numbers to number the frames. The sequence numbers are based on modular to arithmetic. In stop and wait ARQ, the acknowledgement number always announced in modular to arithmetic the sequence number of the expected next frame. This is the design of stop and wait ARQ protocol. A sender sends this frame to the receiver and wait for this acknowledgement and wait up to the time out. This is the flowchart for the stop and wait protocol on the sender side. This is for the receiver side. Figure shows an example of stop and wait ARQ. Frame 0 is sent and acknowledged. Frame 1 is lost. This is the example where we send a frame 0 sent by a sender and received by the receiver, and we get the acknowledgement. And in the frame 1 it is lost in between, and we didn't get any acknowledgement, and we start the timer, and after the timeout it is restart, and then send resend is frame 1, and we get the acknowledgement. Next we send to the frame 0, and in this case the frame is reached at the receiver, but somehow the acknowledgement cannot send to the sender. Then after the time out, it will resend to the frame 0, and when then get the acknowledgement. This is the stop and ARQ. In the go back and protocol, the sequence numbers are modular 2 to power n, where n is the sequence size of sequence number of fields in the bits. This is the send window for go back and ARQ. In the send window, here we are showing that the frame sent but not acknowledged is outstanding. And the next window, the frame that can be sent but not received by the from the upper layer. The send window is an abstract concept defining an imaginary box of size 2 to power n minus 1 with three variables s to power f, s to power n, and n as size.